Hi everyone. I'm going to get started on going over the final review, and then I'll post this since you'll be watching the recording. So the way this is going to work is this is basically just going to be like a final, like a practice final. So we're going to have some true or false questions and then also some questions with more math. And so we'll just go through these one at a time. So hopefully this is helpful for your AI practice final and then also the actual final. So we're going to start with the true or false questions. So here's the first one. So evaluate the validity of the following statement. If the statement is not accurate, explain why and how to prove it. Be sure to use an equation or an example to support your explanation. So the first one. When a business sells a piece of equipment for an amount that is lower than its original purchase price, the company must always record a loss of sale in their journal entry. So I'm not going to pause in between these, so if you want to pause to try and do this, just do that after I read the question. So this statement is incorrect, and then here's the explanation I gave for this. So whether or not you have a gain or a loss on the sale of equipment is not determined by comparing the sales price to the original purchase price, like whatever you paid for it originally. Instead, you should compare the sales price to the asset's net book value at the time of the sale. And so in order to improve this statement, you would say when a business sells a piece of equipment for an amount that is lower than its net book value, the company must record a loss on sale. And that would be accurate. And so the idea here is if you buy a piece of equipment and then use it for 20 years and then sell it, it makes sense that you would be getting sort of less than the original purchase price. But that doesn't mean that you're recording a loss because you also got to use that equipment. And so that equipment sort of deteriorated and lost value over the years, and so then that's what you want to compare with for the sale. Okay, next true or false question. So imagine a popular skateboard manufacturer, Shred Company. Last year, Shred Company's profit margin, so how much money they keep from each sale, and their asset turnover stayed exactly the same. However, the company reported to the public that its return on equity skyrocketed, so it increased. A group of skeptical investors reads the report and makes the following claim. It is mathematically impossible for Shredco's return on equity to increase if their day-to-day profitability and efficiency didn't improve. Therefore, this financial report must be fake. Okay, so pause here if you want to try it. Okay, so this true or false question is also false, and so the investors are wrong. So this question is basically testing you on thinking about the DuPont decomposition. So Shred Company's report could be completely real, and this is sort of why. So if we look at the DuPont decomposition formula, which decomposes the return on equity into, in this case, 3 factors. So before, the investors were kind of looking at only 2 factors and determining that since those didn't move, the return on equity can't move. But then if you look at the DuPont decomposition, you can see that the return on equity is equal to the profitability, so the return on sales, efficiency, the average turnover ratio, and the financial leverage. And so the investors were sort of right that the ROS and the asset turnover, ATR, didn't change, but they weren't thinking about this third factor, which is financial leverage. So it could be that Shred Company just borrowed a lot of money, so they took on debt and used that to fund their business. And so if they were doing that instead of using their owner's money, this would sort of increase their return on equity, right? Because the return on equity is equal to ROS times ATR times FLR. And so these aren't moving. But if the financial leverage increases, then that's going to increase the ROE, even though these are staying the same. And so that's the idea of this question. So this is just making sure that you remember all these different decompositions and ratios that we went over in the second half of this class. Okay. So next, true or false question. So evaluate the validity of the following statement. If the statement is not accurate, explain why and how to improve it. Be sure to use an equation or example to support your explanation. If a company decides to use the indirect method for its statement of cash flows, it must apply this indirect method to all three sections: operating, investing, and financing activities. So pause here if you want to try this. Okay, so this is again false. And just as a tip, I think in this class, because these true or false questions are sort of complicated, a lot of the times, not all the time, but a lot of the times, the answer will be false, and it's just figuring out why. And so that's like a good thing to have in your mind when you're thinking about how to answer these. Okay, here's the explanation. The choice between the direct and indirect method only applies to the operating activities section, or the operating cash flow section. The investing and financing sections are always prepared in the same way. And so you don't have to worry about the indirect versus the direct method. You always are just using the direct method for the investing and financing sections. Yeah, so the investing and financing activities always report the direct cash, so the direct cash going in and out, so the direct method. Whereas you do get to make a decision on the operating activities cash flow. But like we discussed before and like you saw in lecture, generally firms use the indirect method for the operating activities section. And so it's good to make sure that you understand it and don't just rely on the direct method. Okay, great. So now we're going to go over some practice problems. So here's the setup for the first one, and then I think it's going to be a three-part question. So your chief marketing analyst has recently discovered a way to extract more revenue from customers by implementing targeted advertising using a novel analytics technique. So here's the first question. If implementation of the technique requires an investment outflow, so a cost, equal to $2 per customer, so it's negative because it's a cost, and the technique is expected to yield an increased revenue stream over the next 3 periods of the following. So remember, this is a revenue stream, and so it's a series of payments. And then this series of payments is going to have 3 periods, so x1, x2, and x3. And the payments coming from this new technique are $3, $6, and $9 in each of these periods per customer. So then we're asked to compute the net present value, sort of at the per customer level, of investing in this technique at a discount rate of 50%. So pause here if you want to start working on this. Okay, so I'm going to write down the information that we need that was from the last slide. So our discount rate, we're going to be using 0.5, and this is from the 50% figure. So remember, I've said this before, but just remember, always convert the percentages to decimals when you're using these in equations, otherwise you're going to get the wrong answer. The initial payment for this technique is $2, so that's going to be a -2 in terms of sort of the direction of cash for the company. And then the payment stream is going to be equal to 3, 6, 9. Okay, so now we're asked to write down, or to find the net present value of this, this technique, this investment. And so we're going to use, because this is sort of finite, and we have all these periods, and we have all the information, we can use the regular formula. So this would be the formula we would use because we have all these periods, and these are our only periods. And then if you plug in numbers, you're going to get -2 plus 3 over, and so this will be 1.5, right? 1 plus r, plus 6 over 1.5 squared, plus 9 over 1.5 cubed. And so then we get -2 plus 2 plus 6 over 2.25 plus 9 over 3.375. And so if you plug this into a calculator, first you can see these cancel out. And so you'll be left with 5.32. And so that's the net present value of this investment. Okay, great. So now part B. So it's the same setup, but now we're here. So, but instead, the increased revenue stream is delayed to the third period. So you're basically not getting any additional revenue in the first and second period, but then you're still getting that 9 additional revenue in the third period. And then what is the internal rate of return implied by investing in this technique? So this question is also important because now we're asked something slightly different. So we're not asked to compute the net present value. We're instead asked to find the internal rate of return that would be implied by investing in this technique. So pause here if you want to try this. Okay. So when we're asked to find the internal rate of return that's sort of implied by a firm making a decision, what we need to do is now we know that essentially the net present value of this decision to invest will be equal to 0. Okay? Because it means the firm is sort of indifferent between investing and not, and so that means the net present value will be 0. So we're going to start with that. So we're going to start and say 0 is equal to -2, right? Because now I'm just writing out the net present value. So it had a -2 and then x3 equal to 9. But now what's different is we're not going to plug in a value for r, right? Because the idea is to find an r, find a sort of internal interest rate or discount rate that's going to make this equal to 0. So now we're solving for r. So whenever a question asks to find the internal rate of return, you're instead going to solve for r and not the net present value. So then let's rearrange terms here, and we're going to see that we get, okay, so we're going to get 9 over 2 is equal to 1 plus r to the third. And so 9 over 2 is equal to 4.5 plus r cubed. And then you're going to take the cubed root of both of these equations, so on both sides of the equation, and so you'll be left with 1.65 is equal to 1 plus r, and so then r will be equal to 0.65 or 65%. So whenever you see internal rate of return, remember you're solving for r. Okay, perfect. So here's the last question on this setup. So the outflow is still the same, so it still costs $2 per customer, but now instead we're getting a perpetual increase and perpetual increased revenue stream. And so here, what that means is that we're going to get payments every period, basically for forever. And so now we write this as x1, 2, 3, 4, ... And so the dot 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 just means that we're going on and on and on. So there's no end period. And so each period we're getting $3. And then we're asked to compute the net present value of investing in this technique at a discount rate still of 50%. So now we're just basically testing if you know how to calculate the net present value using perpetual revenue streams instead of finite revenue streams. So I'll give you a second if you want to pause here and work on this question. Okay. So when the revenue stream, the perpetual revenue stream is constant, it's a bit easier to calculate what this should be. And so I'm going to first solve for the present value of just the perpetual revenue stream portion. So basically I'm ignoring this for now, and I'm instead just calculating the present value of the revenue stream. And so when the payments are constant, you can write the perpetual value equal to this. So this is the payments, the payment per period, and this is the interest rate bar. And so in that case, we can see pretty quickly that if we plug in our interest rate and our perpetual payments, the present value of this revenue stream is equal to 4.5. Okay, so now what we need to do is calculate the net present value here. And so the net present value of this revenue stream will be equal to x0 plus the perpetual value of the revenue stream. And so then we plug in our numbers and we have -2 plus 4.5. And so that's going to be equal to 2.5. So that's the net present value of the perpetual revenue stream payments. So I'm not going over it here, but I think one thing that would be worth also reading about, and that I think you have a practice problem on your practice final on this, and so you can either work on that and then also look at the solutions before the final, is also calculating the net present value of revenue streams when there's exponential growth. And so exponential growth. So those are a little different. So first you have to calculate the exponential growth rate and then use a formula from there to calculate the net present value. And so it's good to review that too. Okay, so now we're going to do some different practice problems that are for different topics. That way we cover some additional material. And so here's the next question. If you had to amortize a lump sum payment of $200,000 into a uniform annuity stream with 10 consecutive annual payments at an APR of 15%, what is the size of a single annual payment in the amortized cash flow stream? Okay, so pause here if you want to work on this. Okay, so here this is testing if you know the equations for basically amortization. And so what we're going to do here is use the formula as follows. So the amortized payments, so X, are equal to the present value of the purchase value, sorry, of the asset times R times 1 plus R to the T over 1 plus R to the T minus 1. And so this is helpful. This is kind of showing you that if you don't remember this formula, you need to go back into your notes and make sure to study this for the final, because this is just one of many formulas that you need to know for this class, and if you sort of don't know this, you won't be able to answer this question. So then the purchase value is 200,000. T is 10, so 10 years. And R is the APR given in this question, which is 0.15, and that's from 15%. Okay, so then if we plug in these numbers, so that's what we would plug in. Remember this is 1.15. And so then we would get that the payments per period are equal to 39,850. Right, and that's what we're asked to find. It's the size of a single annual payment. And a good check on sort of if you did this right is, I need to pull out my calculator to do this. Yeah, so a great check on this is to just say, okay, now if I take the payment and I multiply it by the number of time periods I have, I'm getting 398,500. This, and this is greater than 200,000. And so it should essentially always be the case that you're going to get that the sum of the annual payments is going to be larger than your lump sum payment. So that's always a good check. So you're not going to be probably asked about that, but if you do the math and calculate a lump sum payment and you want to check that potentially it's right, this is a good check. And if you get something smaller than your lump sum payment, maybe there's an issue. Okay. So next question. Consider a perpetual bond that makes a constant coupon payment of $200 every other period into perpetuity, so forever, starting in period 1. And so this is what the cash flow looks like. So in period 1 you get 200, in period 2 nothing, period 3 200, period 4 nothing. So then you would get 200 0, 200 0, and so on. So compute the price of the asset at a discount rate of 75%. So pause here if you want to try this first. Okay, so here's the information we need. So x0 is equal to 200, right? Oh, sorry, that's x1. Yeah, x1 is equal to 200. And so the payment stream, remember, is like this forever. 200, then 0, 200, then 0. And so x0, because it isn't mentioned, there's no cost of this. That's basically 0. So we can ignore that when trying to calculate the price. Okay. So if and then r is equal to 0.75. So if we're asked to compute the price of the asset, remember this is exactly like being asked to compute the net present value of the asset. And so I'm going to just write down as an example sort of what this looks like. So in the first period, we'll get 200 plus 1 plus r. And in the second period, we'll get 0, right, because we're not getting paid. And then in the third period, it'll be 1 plus 200 over 1 plus r, remember, to the third, because we skipped the second period, and so on and so forth. And so this would be 0. So this would then be 200 over 1 plus r to the 5, etc. And so if you sort of plug in the numbers just to see what this looks like, you'll get 200 over 1.75 plus 0 plus 200 over 1.75 to the 3 plus 0 plus so on. So because this is a perpetual payment, we can't just sort of do this and then be done. Instead, we need to work with this to get this into a form that basically allows us to use our equations we know for calculating the value of perpetual or infinite sums. So I'm going to let delta, so I'm going to define delta to be 1 over 1 plus r. And so then I can rewrite the net present value that we were just doing as 200 times delta plus 0 plus 200 times delta to the 3 plus, and so I'm now going to stop writing the zeros, delta to the 5, etc. And so what you can do here is you can factor out the common factor of 200 times delta, and you'll be left with 200 times delta plus 200 times delta times 1 plus delta 2 plus delta 4 plus, so then you would have delta 6, so on. And so what I just did here was I just took out the 200 by delta from here, 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 and so on. And so this is an infinite geometric series with, so if you remember your formulas for this infinite geometric series, you'll see that a, the value of a in those formulas is equal to 1, and the common ratio r is equal to delta squared. Okay? So it's important to remember that it's delta squared here, or to recognize that it's delta squared here. And so then this will go to the next page. So then the sum of an infinite geometric series is a over 1 minus r. So that's why you have to just know these formulas. So that implies the sum of this infinite series we have in this question is 1 over 1 minus delta squared, right? Because I plugged in a is equal to 1 and r is delta squared. So our net present value can be rewritten again as 200 times delta over, and so now this was an infinite series in here, but now I can rewrite it as just 1 over 1 minus delta squared. And so then we have to split, in order to solve this, we have a delta squared here, and so let's try and simplify this. So we're going to get the net present value is equal to 200 times delta times 1 over 1 minus delta, 1 plus delta. Right? And so this is because you can rewrite 1 minus delta squared as this product of 1 minus delta and 1 plus delta. Okay? So now I'm going to split this even more. So now I'm going to rewrite it as 200 times delta over 1 minus delta and delta over 1 plus delta. So what I did here is I split these two factors into two different things, and then I distributed the delta from here into those things, and you'll see why I did that. So we need to get this back into an R formula, right? Because we're interested in finding R, not delta. And so what you can see is from this, we have delta over 1 minus delta is equal to 1 over 1 plus R, right? So that's this delta, over 1 minus 1 over 1 plus R, okay? And so then if you work with this and you simplify, you can see this is actually equal to just 1 plus R. And then the other one is um, 1 second. One second, sorry, I have to pause this. Sorry, I had to pause for a second. So here, actually, this should just be a 1, right? Because we move the delta here, but then we don't move it there. So this delta basically just goes there. And so then if you rewrite this, you'll get 1 over 1 plus 1 over 1 plus R, which is equal to, so this one is a little bit harder to maybe work with, but you'll end up with 1 plus R plus over 2 plus R. So yeah, this question is long, but it's good practice. So now we'll go to the next page. So now if we plug in everything, we'll see that P, or the net present value, is equal to 200 over 1 plus R times 1 plus R over 2 plus R. And so then we can start plugging in numbers, and we'll get 200 over 1 plus 0.75 times 1.75 over 2.75. So we're using the interest rate is equal to 0.75. And then we'll get a final answer of 169.7-ish. And so this is the price of this bond. So I think this question is very long, but it's also important that you sort of know how to do all this math and work with the uh, perpetual formulas and the infinite sum formulas. So that's why I did this question. Okay, question 4. So I think, yeah, this question we have 2 parts for, and then that will be the whole final review. So consider the decision of purchasing a new car and deciding whether or not to go with a lease or an outright purchase. If the car is leased, it requires $3,000 at signing, so at period 0 when you buy it, and a payment of $160 a month for the next 36 months. Alternatively, you could buy the car outright for $14,000, so in the first period, or in the period 0, and you already have a friend who you know will pay $6,000 for the car, the used car, after 36 months when you're done with it. So question A is if the effective annual discount rate is 5%, calculate the net present value of each of option. So pause here if you want to try this yourself. Okay, so the first thing we need to do is let's calculate the interest rate at a monthly level, right? Because we were only given the effective annual discount rate. And so we need to know the monthly rate. And so here we can rewrite, or we can solve for the monthly rate by realizing that 1 plus our month to the 12 for each month should be equal to, has to be equal to 1 plus R year. Okay? And so that means if we rework this, we're going to get that R month is equal to 1 plus R year over 1 over sort of to the power of 1 over 12 minus 1. So all I did here is I took essentially like the 12 root of the left and the right side of this equation, and so that would get rid of the 12 here, but put the 1 over 12 here, and then I move the 1 to the right-hand side. And so then if you plug in, so we know our year is equal to 0.05 plus 0.05 because it's 5% over 1 over 12 minus 1. We're going to end up with an effective monthly interest rate equal to 0.41%, or, so remember, this is the percent, so it'll be equal to 0.0041. Okay, so now we can calculate the net present value of both of these. So I'm going to do lease and buy the revenue streams. So for leasing, we pay $3,000, and then every period after that, we pay $160. For buying, we pay $14,000, and then we get 0 because we're not making any payments, and then at the very end of the period, we're getting $6,000. So you could do this different ways. You could write all of these as negatives because they're payments, right? They're costs, and then this 6,000 would be positive. Alternatively, you could do what I'm doing here, which is basically just write these as positives, and then the 6,000 is negative, and then whichever has sort of the lower net present value is actually the best option if you do this. If this is confusing, then I would recommend just, if you see a cost, write it as negative, and if you see a payment, write it as positive. Okay. T are time periods. So this is 36 for both. Our interest rate R is 0.41%. And so then the net present value, so if you calculate the net present value using your net present value formulas for the leasing option, you would get 8,347.4. And if you do it for the buy option, you would get 8,816.97. And so leasing is better, right? Because it has sort of a lower net present value when I did this negative positive trick. So that's the answer here. And so now, last question. What is the effective annual discount rate? For what effective annual discount rate would you be indifferent between either option in net present value terms? So pause here if you want to try this. Okay. So what this question is basically asking for is for us to calculate an interest rate when the net present value, the net present value of leasing is equal to the net present value of buying. So let's write down the equations for both of these net present values. So the equation for leasing is going to be 3,000 plus 160 delta over 1 minus delta to the 36 over 1 minus delta. And so if you don't know where this came from, I would recommend going back and reviewing all the different formulas we have for calculating the net present value when we have, yeah, and this would sort of show up there where you can rewrite these payments sort of with a sum to the t, and t is 36, and so you can rewrite things into this formula. So that's leasing. Buying is a little bit easier. So it's 14,000 in period 0, and then in 36 periods, you're basically getting that payment of $6,000, but it's in 36 periods. Okay. So here, this is sort of a complicated formula, and so what I would recommend you do is either figure out how to solve this yourself, which is quite complicated, or instead learn how to solve these on your calculator. And so you can sort of rewrite some of these things to end up with basically an equation that lets you solve for delta. And then once you do that, you'll see that based on that value of delta, the interest rate that you would get is 0.029. And so what this means is that if the effective annual discount rate is higher than sort of 2.98%, you're going to prefer leasing, and if it's lower, you'll prefer buying. And so I'll post, I think, a slide sort of walking through this math. I think most of the time on the final, you won't need to do this type of math, but it's good to know how to do it just in case you need to do it. Okay, so that's it for the final review. Good luck on your final, and let me know if you have any questions about any of this.